All right, this is number 1 from Solving Trig Proofs worksheet number 2. So you should have already done worksheet number 1. That one was a little bit easier than this one. So again, the same properties apply though. You're going to choose either the left or the right side to start with, and then you're going to manipulate it using some algebra to get it to be equal to the other side. So on this one, it doesn't really matter, so I'm going to go ahead and start with the left side. Now, I gave you a hint in class. Remember, we want to get this bottom to be equal to tangent. Well, the only way I can change secant to tangent is if it's secant squared somehow. So I gotta think, is there any way, or what can I multiply this by to get secant squared? Well, remember, we talked about when you multiply by the conjugate. So that would be secant of x plus 1. Your middle terms are going to get canceled out, so then you'll get a secant squared and then a plus 1 or a minus 1. And then you're going to do the same to the top. So you can just remember to multiply by the conjugate. The other way to think of it is I know I want secant of x plus 1 on top when I'm done. So why not just times it by secant of x plus 1? And the reason I have to do it over itself is so that's equal to 1, so I'm not actually changing anything. That's what I mean by manipulation. So I'm not going to FOIL the tangent through, and the reason why is I know I'm going to want to end with secant of x plus 1. So I'm just going to leave it as tangent of x times secant of x plus 1 all over. This I am actually going to FOIL out. So, because I'm timesing all of this by this, secant of x times secant of x is secant of x squared. Secant times positive 1 is plus secant of x. And then negative 1 times secant of x is negative secant of x. And then negative 1 times 1 is negative 1. So then I'm left with that. Again, because these were conjugates of each other, meaning this middle term got switched, these cancel out. So then I'm going to be left with tangent of x times secant of x plus 1 all over secant squared of x minus 1. Now, we have that squared we wanted. And my hint to you was anytime you see that squared on our trig functions, think of your Pythagorean identities. Well, remember, and I will write these 3 up here, you should always write these on the top of your paper. Keep them somewhere where you can see them. So you're left with, and then tangent squared plus 1 equals secant squared. Since I'm dealing with the secant squared one, I want to see what secant squared is equal to. That's equal to tangent squared plus 1. But I could also rewrite this in minus 1 over, and then I'd get secant squared minus 1 is equal to tangent squared, which means all of this can be rewritten as tangent squared. So my top remains the same. I did nothing to the top. Again, all of this we said could be rewritten as tangent squared of x. Then I'm almost to where I want. I got my secant of x plus 1 and I got a tangent on the bottom. You could rewrite this out. Again, for some of you, you don't have to rewrite this step out right here. You do need all the rest of these steps, but this step you wouldn't need. I can rewrite tangent squared as tangent of x times tangent of x, so then the tangent of x's would cancel out. Oops, on the wrong one. Jeez. And I would get secant of x plus 1 on top and tangent of x on bottom, which is what we wanted. So put your box to show we got to where we wanted and we proved what we set out to prove. So that's number 1 on that worksheet. Now number 2. Number 2, you can choose which side to start off with. I'm going to start off with the left side. So we always rewrite it saying, hey, this is where I'm going. Now, I want to sine square it at some point, but there's nothing I can really do from here. So I'm going to actually multiply by the conjugate. When in doubt, you can always try the conjugate as well. Because when I do that, so if I times the top by it, I need to times the bottom by it, and vice versa. I'm going to FOIL these out. So you're going to get sine times sine is sine squared. Sine times negative cosine is negative sine x cosine of x. Sorry, I'm tired. And then you'll get cosine times that, so I get negative cosine x sine x. And then plus cosine squared. So I just FOILed out the top. And then I got to FOIL out the bottom. So then I get sine squared x minus cosine x sine x plus cosine x sine x and minus cosine squared of x. Alright. Then, again, I don't know if this is going to work. I'm going to try it. So I'm going to get these. They will cross out. These can be combined because they both have a sine and cosine. So they are like terms. So then I get sine squared x minus 2 sine x cosine x, because they had two of them, plus cosine squared x, all over sine squared x minus cosine squared x. From there, I have a trig identity. These two, sine squared plus cosine squared, that's equal to 1. So I get 1 minus 2 sine x cosine x. And I don't know what this is, so I would leave it. And that's really similar to what I kind of wanted. But notice, I got this on top. I wanted something very similar to that on bottom. So that means none of this worked. But I was close because I got something very similar to that. So then instead of doing the conjugate of the bottom, I could try and do the conjugate of the top. So again, sometimes you have to try them. And I wanted to show you that because most people think they can only times by the conjugate of the bottom. And notice we got very similar, but it wasn't where I needed it to be. So let's try timesing this by the conjugate of the top, which is sine of x plus cosine of x over sine of x plus cosine of x. See if that gets us any closer. So remember, if you're doing it, it's okay to not get anywhere where we need to be and try again a different way. We got really close, so let's try it with the conjugate of the top. So sine times sine is sine squared x. And then this was a minus. I wrote it wrong. Sine times cosine is plus sine x cosine x. This will be negative cosine x sine of x. And then negative cosine squared of x. Oop, you can't see that. Sorry. And then the bottom will now become sine squared x. I'm going to go kind of fast here. Plus 2 cosine x sine of x plus cosine squared of x. And all I did was FOIL that out. You guys kind of got used to that. Now on the top, these will cancel out. So we're left with sine squared x minus cosine squared x all over, and then these, that's a trig identity. That's 1. So 1 plus 2 sine x cosine x. Hey, our bottom is what we needed it to be. Now the only thing is our top isn't quite. Jeez, I'm tired. The top only has sine squared in it. So the only thing I can really look at, this isn't a trig identity, but I can rewrite this as sine squared. So I'm going to go ahead and do that. So I get sine squared of x minus Well, remember, cosine squared x is the same as 1 minus sine squared x. So I just rewrote cosine in terms of sine using my Pythagorean identity. And then it's over the bottom, which is what we wanted. So then I can distribute this negative. Boop, boop. I get sine squared x minus 1 plus sine squared x over all my bottom again. All right, like terms, I have a sine squared plus a sine squared. That's 2 sine squared x minus 1 over 1 plus 2 sine x cosine x. And we are done. We finally got it to where we wanted. Now, again, this is just showing you. Sometimes we try it one way because we always think the conjugate of the bottom. We got pretty close, so I tried the conjugate of the top one and got where I wanted. So even though this didn't get me where I needed to be, it gave me a hint on where to go. So remember, this doesn't mean you failed. This means you found a way that doesn't quite work, and it can help us find a way that actually does work. So that's how you do 1 and 2 on the second worksheet.